There's no earthly way of knowing how your infrastructure's growing, or who knows how business is going, or which way the data's flowing. Drives imploding, I/O plateauing, is a hurricane a-blowing. 100 alerts are showing, so the danger must be growing. Are the status LEDs a-glowing? Is the server Reaper mowing? Yes, the danger must be growing, for the data keeps on flowing, and they're certainly not showing any signs that they are slowing. Come with me, and you'll be in a world of systems automation. Take a look, and you'll see into my chef lucubrations. So log in, install, begin with the chef cookbook of my creation. What you see might require explanation. If you want to view paradise, simply go to GitHub and view it. Pull requests are welcome, go to it. Want to change the code? A merge will do it. There is no life I know to compare with writing automation. Write it once and you'll be free to play Diablo 3. If you want to scale past a petabyte, just install Chef Salt and Graphite. If you want to sleep the whole night, automate the world. It will be alright. There is no life I know to compare with writing automation. Write it once, you'll be free. If you truly wish to be. Milford. I run ops in the US for Outbrain. The other thing was just me messing around. I hope you enjoyed it. This is not really strictly a Cassandra talk. I'm going to be talking about the automation stack at Outbrain, and moreover, how it specifically applies to getting a Cassandra node from bare metal, and actually before that, ordering it into a rack, provisioned, and actively working as part of your Cassandra cluster, or my cluster, because you don't have these tools yet. You should. I talked about 2 years ago. I'm an ops guy. I'm the token ops guy. Are anyone else here ops people? Sweet. Those are my people. Right. Feeling it. Yeah. Anyone else here a developer who is by default their ops guy? Yeah, you're my people too. I write code. No big deal. Humble brag. 2 years ago, I gave a talk about what we do at Outbrain and how we do Cassandra, and mainly about how to be a sysadmin working with Cassandra. You know, it's not that big of a deal, except for 2 years ago, we were at, what was it? What did I put up here? 30 billion impressions a month. We had 14 nodes and 1 use case for clusters. We grew. And we do about 80 billion impressions a month. And impressions are a tricky thing, because we have a multi-strip widget. So each time it hits that, that's an impression to call that. We've got 4 clusters, and I just put in yesterday an order for hardware for another cluster to separate our counters that we use for our Kafka storage infrastructure and move it to a separate cluster, because multi-tenancy sometimes can be pretty bad. We have 3 data centers. We've got, by the end of this week, we'll have 73 Cassandra nodes in production. It's kind of crazy. This year, in the last 2 years, we scaled up to about 1,000 servers. We've got 3 miles of Ethernet cables. We've got 7 tons of servers. I don't know how many kilowatts we're eating up. We kind of need automation to be able to do what we're doing. And a lot of what I'm going to talk about in the coming slides was stuff that, you know, if you run on Amazon, probably already got it built in, but we had to build our own because our I/O is so hardcore that we won't fit on that Amazon. No big deal. Oh, and I forgot to mention, my buddy Nick Cage called, and he was like, "How am I not in your presentation?" Because it's extreme. So we had to come up with an automation attack plan, and how we went about that was splitting apart all the different parts of how you go about automating your cluster, the different phases that something goes through in its life cycle. We started off with provisioning, from ordering, receiving, racking, getting an operating system on your node, getting Cassandra on the node. We moved on to orchestration, where you keep metadata about that node, where you make decisions and run triggers about what to do with that node as it passes through different parts of your automation. We have config management. That's pretty self-explanatory, but it's also about config enforcement. We have a command and control layer. Command and control is very important if you made a change in Chef or Puppet or CF Engine or what have you, and you have that oh crap moment, and you need to run a live command across all of your infrastructure. Or, I don't know, if DNS messes up and LDAP goes down and you need to restart NSCD across your entire infrastructure. Happens more often than it should. And then monitoring and learning, which isn't necessarily automation, but we automate the adding and removal of nodes. And probably out of all of that, monitoring and learning is probably the hardest part. So provisioning. Even before we started with Cobbler, we did handmade Kickstart files. We're sent to a shop, and I'm actually in the first phases of migrating us to Ubuntu in different places, because all the cool toys run easier on Ubuntu, it seems. A lot of these tools that I'm about to talk about actually would have worked a lot better on Ubuntu, and I wouldn't have to roll so many RPMs for goofy Ruby versions. We moved on to Cobbler, which I think is an absolutely fantastic piece of software. It can provision servers, manage Kickstarter, it can actually do Ubuntu too. It can deal with power profiles, templating, all sorts of wonderful things. But every high-performance infrastructure is a snowflake. And at some point, all the off-the-shelf stuff in the world, all the OpsView, all the Tivoli, all of the different pieces that people sell or open source, it's just not all going to work. And you need to take all those pieces and glue them together. There's just no tool, and it won't write itself, so we've got to write our own. We started off about 2 years ago when we identified that we were going to have this problem, and we started building a tool called OneRing. And I'm not really a huge Lord of the Rings fan, but Ori, our CTO, really liked the idea of it. It's the OneRing to rule them all. It holds all our metadata and controls pretty much everything. 2 years ago, Ron Tavori actually started the initial code for it. He was, I think, the granddaddy of the Hector. So you may recognize his name. Oh, and it was also partially inspired after that when we found out about Tumblr's Collins at Velocity last year. Josh Hoffman talked about his Collins orchestration mechanism, and I just fell in love with it. It was fantastic. OneRing handles provisioning and orchestration. It initiates and manages provisioning of inventory, acts as orchestration layer in our automation, keeps all metadata, which is searchable. And the guy who wrote most of this, most of the modern code for it, is a guy named Gary, who is fantastic. He built a CLI tool, a REST API, all sorts of fancy stuff. And it acts as our single point of truth and the authority for all state in our infrastructure. And I say that right now knowing that it's a little bit of a lie. We're still migrating everything over to it, but eventually we'll get there. So this is kind of what OneRing looks like. Shocker, Bootstrap. You can see some of the information. It integrates with Chef, it integrates with Blue, which we'll talk about a little bit. We can redeploy nodes. We're trying to get to a place where machines get a calculated hardware ID that is immutable and does not change. It's not a serial number, it's calculated from immutable parts of the hardware. So if I just put Ubuntu, I put FreeBSD, I put Lumos, whatever the heck you want on there, it will recreate that same ID so that we can track the life cycle of the machine as we rechange its roles. And if we change a role and we make something a Solar node and then we turn it into a Cassandra node or something like that, we can track its life. You can see this guy was paid at CO1 and then had a different name, several different things over its lifetime. But it's really nice to track that. And also, you need to track that if you want to track hardware issues over time. So here's our one-ring provisioning workflow. One of our developers comes up to me and says, Nathan, I need some more Cassandra nodes. And I'm like, awesome, let's do that. So they go into one ring, and actually, this is one of those things that's not ready yet. It's actually a spreadsheet. But they will go into one ring by the end of next week. And they will fill out a form that says, I need this type of machine. We're trying to simplify our machine orders down to specific hardware types, kind of like an Amazon API. We got medium, large, extra large, small. They put in requests for machines. Machines show up. 3 to 4 weeks later, get racked in one of our data centers by one of our fantastic engineers, Sarah, who manages all that. They boot. They boot into the Razor microkernel. Microkernel then shoots an inventory back to one ring and says, oh, I'm new. Good to meet you. You're this type of node. This guy's waiting for you and should start provisioning it, turning it into a Cassandra node, turning it into a Solar node, or one of the internal modules we use. Appropriate nodes get kickstarted, bootstrapped into the role specified. Additional nodes sit idle in an allocatable state, so we tend to overorder for extra capacity. And then once the operating system installed, configuration's handed off to Chef. And if you listened to Eric's talk earlier today, he's a fan of Chef too. I'm a big fan of Chef, but you can do everything that I do here with Puppet, BCF, CFG2, config engine, config, whatever. There's like a whole bunch of them, Ansible, Salt. One ring bootstraps to Chef run. Chef installs all the system stuff. We have a base role that runs. And actually, if I go back, you can actually see under Chef, it has the OB base role, and it has the OB app API role. It sets up a Java version. We're migrating to 7 right now, because 6 decided to end of life on me, whatever. It tunes the OS how we like it, and then it runs for a Cassandra node, and that's how I can make this talk relevant to you. It runs the Cassandra cookbook, which in its most basic form looks like this. Include recipe Java, assuming we have a Java recipe, package Apache Cassandra do action install end, and then it drops a templatized herb, templatized Cassandra YAML. If data staff people are here paying attention, and I assume they are because this is their, shindig. The naming of the RPMs have changed from recent release. It really messes with my, really messes with my templating. Consistent. Thank you. My Cassandra cookbook does it all except for node rebalancing and calculating tokens, and I'll get to that in a minute. It builds and mounts the disks. It handles multiple clusters with different versions, which is really hard when the RPMs are named different things. Generates configs in some place automatically based off of the hardware profile. So if I order a node with 12 cores and 32 gigs of RAM, and I order another node with, I don't know, like 24 cores and 8 gigs of RAM, it'll calculate the concurrency and other things based off of that metadata. It will connect, and it won't do it on the first time it installs it because there's nothing there yet. But by the time it does its second run, which it runs every 30 minutes, it'll connect to the local instance of Cassandra. It will pull the schema information off, and then it will generate a collectee configuration. It will pull all of my key spaces and column families, and it'll iterate and create a configuration so I can get all of the MBs for all of the things ever. And it generates a maintenance script, which is just a very simple script that just iterates, clean up, repair over everything. It'll schedule the maintenance, so it'll divide by 168 hours in a week or whatever it is, by how many nodes I have in a cluster, so we can evenly distribute when repairs and that sort of stuff happens. And it will also drop and Camarillo's Dr. Real-Time cron tab entries to change compaction thresholds during different hours of the day. So this isn't Cassandra specific, but this is how we deploy nodes that use Cassandra. We use Glue for our continuous deployment architecture. It was originally written in LinkedIn. OneRing talks to it. OneRing actually gets information out of it. It holds the deployment metadata, and right now, kind of the basic workflow is you specify what module you want to install. It does a Maven build, and it builds an RPM. It puts it into a repo in each of our data centers, and then a local Glue agent on each node. I think it's written in Grails. Yum installs it and performs checks to validate it's there, and it actually uses Zookeeper to keep that information. This would be how you deploy, but you can also deploy with SVN. Don't judge me. You can deploy with SVN with a hashtag deploy. You can also upload chef cookbooks, by the way, with hashtag chef deploy. No big deal. You can see people deploying things right there. This is sort of our internal sugar for it, called Glue Feeder that Ron wrote. Command and control, and this is my favorite picture of the entire slide deck, and I don't know why I put it there, but I just really needed to put it in here. Salt Stack is a fantastic thing that Gary discovered. I'm very happy with it. It sort of competes with Chef, but we don't use the configuration management aspect of it. We use the distributed command aspect for it. We looked at a bunch of them. We looked at Funk and Cassandra and stuff like that. We actually looked at mCollective for a while, but my level of Ruby could not deal with the awesomeness that mCollective was. You had to write too many separate things. So, you know, if you have just a regular old ops dude like me who can write Chef Ruby, then you may not use it. This works for me because it runs in Python, which I'm more comfortable with. It uses 0MQ, you set up a low master, you can set it in multiple data centers and syndicate between them, and it has a Cassandra module. It actually, I have my Cassandra cookbook installed PyCassa everywhere, and it actually can connect to the local instance, and you can run pretty much all the node tool commands on there. You can run them with globs, you can run them with regular expressions, and then you can do super scary, creepy things. Oh, I don't know, like salt star RMRF / which I would recommend. You can do things like service restart Cassandra and run a node. You can run a node tool snapshot across your entire infrastructure, and you can do it in batches. You can do batch size percent, you can do batch size 2 at a time. It's actually pretty simple. We actually wrap we wrap the command in the one ring CLI tool that we have. So we don't type salt, we type one ring. And one that allows us to do AAA authentication, authorization, and accounting. And it also lets us use one-ring metadata for targeting. So if I want to run a command across all the nodes that have a particular module installed, that's some sort of internal proprietary Outbrain thing, no big deal. So monitoring's hard. There's the famous monitoring sucks hashtag. And now there's the monitoring love one, because people are starting to figure stuff out. At the end of this month, Jason Dixon, I think he's at GitHub now. He's in Boston running the Monitorama, which sold out this year, but all the cool kids are going, and they're going to be talking about OpenTSDB and Graphite and all Sensu and Freeman and all the hotness. So I recommend you try to go next year. So one of the things we've decided to do, and this is my boss Gil's idea, and he's a genius for it, is to have common monitoring and event bus infrastructure-wide. We had to scale up really quick. For a long time, it was just me and Gil. I started up with like 30 nodes, and then when we got like a couple hundred, we started adding people. But now I think we have like 10 ops people in New York and Israel, and it's getting to a point to where, you know, I've got the biz dev people coming up to me asking questions, and they've got the R&D folks in Israel coming up with them, and our daily objectives are getting slightly different. I get different questions asked of me every day. So one of the big pushes for automation this year for us is as we start having too many things going on, as we're all unable to effectively communicate everything that's going on all the time, is to create API endpoints for everything. I don't need to know how Rob or Ariel set up DNS. All I need to know is how to add nodes. I don't need to know how to add or remove nodes, or how it's actually done. I don't care. I just need an API. You know, we're building a little tennis like this. So a big part of that is common monitoring event bus. Metrics, events, metadata, it's all put in there. Right now we use collectd as a systems agent to collect stuff. RabbitMQ. Actually, our internal apps use a library that writes directly to RabbitMQ as the messaging bus, and Graphite as the metrics endpoint. We're working on an events mechanism. It's kind of in the stars. Each layer should be interchangeable. We chose these initially because, well, you know, they work together out of the box, more or less. But I know that, or I believe I read that LinkedIn wrote Kafka specifically for this use case, and then everyone else started using it for Hadoop internally and stuff like that. So, you know, one day maybe we'll just drop it Kafka. Who knows? collectd, it's been around forever. Had to rebuild the JMX plugin to not use OpenJDK. Oh, that's another RPM packaging thing. Not requiring OpenJDK, so I can use the Oracle JDK It's easy to write plugins and extend. It writes RabbitMQ out of the box, and it's easy to templatize in Chef. And this is what a Chef group template looks for, and I'm just iterating through the key spaces there. RabbitMQ, lots of apps support it. We're using Shovel plugin for multi-site. It's pretty stable, and I'm not mad at it. Rob on my team is running it, and I don't know much more about it than it's written in Erlang. And if you have to configure the Shovel plugin, you have to understand Erlang syntax because people are too good for you. Graphite plays well with RabbitMQ, easy to get metrics into, and that's actually not Graphite up there. That's actually a D3 rendering of our general dashboard. It's got scads and function. It's easy to get data out of. Quick note about our Cassandra dashboard internally. It's actually getting stuff out of Graphite, but you can put a little thing in the Graphite URL, and instead of rendering an image, it'll give you JSON back. And then online recent reads write latency for the online cluster. You can see something happened in LA. Blue's always New York, green's Chicago, red's LA, and something happened. I don't know what that is. I don't want to know. Graphite's really super awesome if you want to be able to get ad hoc data out of it. I sort of add character terms to make this more readable, but you can render the width and the height. You can do the however many hours until when, and then you can target. I have sort by maxima, so the highest, and then I have the highest current collect D in our Cassandra 2 cluster, read stage pending tasks, and mutation stage pending tasks. And it comes up with something like that, and it's just easy. I can just write that ad hoc as you will. So alerting, not just self-service, and this is really fresh in our environment. For us, it's the holy grail, especially when you've got me in the States writing automation, and I'm building the Hadoop clusters, and I'm building Cassandra clusters, and everyone in Israel and our Israel office is using it. And I'm not always sure what they're working on, and they're not always sure what I'm working on. It uses OneRing for new node discovery, because it's our metadata store. Developers add their own alerts based off of Graphite data, so they can take a URL, like we saw 2 slides ago, cut and paste that into a template, then it will, and you can apply functions. So if you want to have the average of everything, or look at a specific node, you can add it that way. The great, wonderful thing is ops get fewer alerts about things that we don't know what they are. And we're not a bottleneck, which is the main point of a lot of the automations that we get out of the way the developers to let them, develop. And the devs are more engaged. They get to write checks that are meaningful and matterful to them. And they're more responsive in off hours. They're sending things to me before I notice them because I don't have these alerts. It's flipping fantastic. Everyone's happy. And I don't use the word DevOps a lot. But I feel like that's sort of a DevOps example. So I probably got a lot of time left. I've been talking for about 30 minutes. And I can talk about a couple different things. I can talk about Cassandra hardware that we use. I can talk about disaster recovery after Sandy. We lost an entire data center. Or I can pull up some of the Chef cookbook and walk through it. Do we have any preferences? Or I can just stop and put you all out of it.
Do another dance.
I didn't do any dancing. I did not do any dancing. I did a poem recital, and I sang a song.
I'll take another one.
You'll take another one. All right, well, I'll talk a little bit about hardware. We're a Dell shop. We use the Dell C series for the most part, and we're actually considering changing our hardware profile. For simplification's sake, we use the same hardware we use for MySQL, which is right now it's a Dell R620 with 12 cores and 64 gigs of RAM and 10K drives. And Cassandra really likes that. But in several of our different clusters, we have an online cluster where I have sort of like a 5-ish millisecond latency SLA, and then we have an offline cluster where, someone could be hammering it and we could hit it with 300 or 500 milliseconds at a spike. I'm not proud of it, but it happens. Depends on, how your schema is and what you're reading and writing and your access patterns, but most of you know that better than I do. What I think we're hoping to do is move to the Dell C series, which are 6220s. They're 4 nodes and 2U, and they're fantastic. We use them almost everywhere else. Out of 4 nodes, because they're sharing a common power bus, you save an amp. You save 2U, you save an amp. You're able to cram them in there. You can put the same CPUs, you can put the same RAM, and you can put less disks in there. We're probably going to start moving to, SATA, SAS, SSDs. We use the VRNet Flash in our MySQLs and we really like it, but I don't really want to spend 15, 20 grand for Cassandra new, because I don't think it needs it. That's a little bit about hardware. Disaster recovery. During Sandy, we lost an entire cluster. We lost an entire data center, actually. And we were actually getting ready to do a data center move from one facility to the other because the other place couldn't meet our space requirements. Sandy hit, it went offline, and we got the cluster back up and the data center back up within GC gray seconds, which was awesome because it came back up. And while the DBA side of the house had to spend a lot of time reseeding MySQL nodes. And by the way, we have a single master setup for one of our MySQL topologies, and that had to migrate to our LA data center in a pinch. This black magic happened there. I don't know how they did it. They didn't have the GTIDs yet. The Cassandra cluster just, turned it on. Just happened. Status. That's all I'm saying. It just came up, ran some repairs, and I just went and had a beer. I didn't do anything. I just stared at my graph. No big deal. Then we took it back down after the repair because I was out in Delaware for pumpkin chucking, and I got a call from my boss in Israel. This is how we roll at Outbrain, and he said, "I'm flying to New York tomorrow. Rent some vans. We're doing a data center move tomorrow." And that's kind of a big deal. We moved, I don't know, 400 or 500 nodes in a van over a couple of days and turned it on. And then brought Cassandra back up. And then we did that within GC gray seconds. No big deal, just work. I don't know how much time do I have left. I'm not going to do a super deep code dive. I mean, I could run, but I don't think I need to. But if anyone here is not too familiar with Chef, I'd be happy to. But otherwise, I'm willing and able to take questions.
Code dive.
You want a code dive?
Yeah.
Okay. Let me put down my cane here. All right. I've had that stuck in my head for weeks since I've decided to do it. So this is a little, I have a version of this cookbook on my GitHub, and it may or may not work yet, because I have to strip a lot of internal stuff out that doesn't make sense for you. But let's do this. All right. Boom. So we prefix internal cookbooks with OB. So I have OB Java and OB collectd as dependencies. I have a library for Cassandra helpers to add information to it. I have a library for Cassandra helper functions and methods, like what cluster, that will actually find out based off of one-ring metadata what cluster your node belongs to. It installs the Cassandra package. I pin it at a version. I drop the JNA jar, which is not a very pretty way I do it. I drop the MX4J jar, which is really not a pretty way I do that. I define a service. I have a function that creates directories. It builds the disks. I have a function that will drop the environment and actually calculate the heap based off of what's available, and then stop it at 16 gigs because I don't really want to deal with a heap bigger than 16 gigs. Sorry. Topology, I build the topology. All of the nodes metadata are kept in data bags in Chef, which are little JSON documents that are little key value things. I get the seeds for the cluster. I drop the Cassandra conf. I drop a custom init script that does a graceful shutdown because, I like to drain my nodes. I drop a collectd config, and then I calculate the maintenance window. Then I do Mr. Batch and Dr. Realtime at copyright 2009 or whatever. And then actually I manage snapshotting. I have a little script for one of our clusters that we actually care. That just snapshots the data every 4 hours, unsnapshots it, snapshots it, unsnapshots it, snapshots it. Nothing more ornate than that. We don't really have data retention that needs to be more than that. So I will share the library with you. Cassandra helper. Here you can see what the schema of the data bags are like. I have an ID for the host name, so when we search the data bag, I guess the primary key is you search by host name. We put data center and rack, and like was mentioned in the, we effed up, so you don't have to talk this morning. I think Ed said it actually. I put everything in the same rack in the data centers, everything. I only really use the data center as the abstraction, and everything's magically in rack 1. It makes replication simpler to understand. I search the data bag. I have internal things that say node type, and based off of that, whether it's a cast 1, 2, or 3 node, it'll define what cluster it's in. I set up the disks. All the cool kids are using ext4. I check for all the, SDB is built there, which is usually a RAID pin across the rest of the disk. OS is on RAID 1 with commit log. I clear it, put a GPT label on it, part it, make FS, and I learned about lazy itable init, which does all the formatting in the background, which is really fantastic. That's not supposed to be there. Then I drop the directories, I create the directories and set permissions. I search the data bag for like the first 2 nodes, and those are the seeds. I discover the Cassandra schema. It does Chef's gem. It'll install the gem in Chef's. Well, in the version of Chef I use, the embedded Ruby it has. It'll install the Cassandra CQL gem. It'll create a hash. It'll connect to this local server's IP address on the Cassandra RPC port, which we've defined. Connects, gets the schema. I actually drop system and op center because, well, I don't necessarily need to do maintenance on those. Maybe I should. Does anyone do maintenance on their system and stuff, or do they just let it go? Cool.
I just do it, but I have nothing better to do.
Here I build a topology because as I add nodes, I have to dynamically search through the data bags, grab all the metadata for the data center and rack, and then populate the topology.properties because network topology is awesome. Then I calculate the maintenance window, and that's pretty much there, and I will show you real quick. And all of this is, you can do pretty much all the same stuff in Puppet or anything else that you want to do. Here's my collect deconfig, and I iterate over Cassandra key spaces, and it's really long because they're all the NBeans in the world. Look at all those NBeans. Pro tip about collect D. There is a limitation because there's really written by sysadmins who thought they were only collecting memory and CPU and junk like that. When you start collecting Java NBeans, and Java being as verbose as it is, and you have Java lang type, garbage collection name, concurrent mark suite, factory creator, creator, factory, implementer. There are 63 character limit in what collect D collects. So if you have really long column family and key space names, they will get caught. So we're hoping to either move away from collect D or rebuild collect D to actually enlarge that. But I don't know how much that's going to destroy it. And that's not going to be my problem. That's going to be my buddy Rob's problem. So that's what being the boss means. Okay. I'll show you the Cassandra YAML. Look at that. Very simple. At the top of every template, I like to put a generated by chef or node name, so people know when they go into it, they are not, if they make a change, it's going to go away in 30 minutes. And I don't know if there's anything else I really need to show you. I can talk mostly about the chef stuff. That's how I generate the Cassandra topology. Crap, I got 15 minutes. I totally did. Anyone want to talk about anything else Cassandra related? Any questions?
What is the typical data size that you serve on the web?
And it actually changes depending on what cluster. So our algorithm cluster or offline cluster, like right now they're rebalancing it because they just added a metric ton more of nodes. I don't know how many we just added. And before that, We actually don't have a lot of data per node because we like parallelize it across it, and we're really harsh on it. That has, I think, like 50 gigs per node. It's not super deep. I know people will put like a terabyte on each node, but I like to keep it light. The online cluster, which is front-serving stuff that will have document descriptions and stuff like that, that's actually even smaller. But we are looking at using Cassandra for, there are 2 use cases in MySQL that we want to get away from. And then
Only 2?
And then there are cases we use Mobile FS or Mobile FS, I don't know how people say it, for a distributed file system, and we kind of want to move away from that. We store images and we store documents that we've crawled in it, and so we're thinking about maybe storing Cassandra, but I haven't tested how like blob data goes in there. So it's all over the place really, but we don't use it for deep store stuff. The algorithm stuff, we use TTL, so we have, depending on the column family, stuff for the last 2 weeks or a couple months, and then it rolls off. Anyone?
What sorts of heuristics do you use to understand how you're going to scale out your cluster?
And see, like if it was you who asked that this morning, I was itching to answer, because this is how I feel about it. Cassandra is like a sailing ship. It's like a big sail ship, and if like you're the captain of a ship, because you can build your schema in several different ways and get different performance out of your cluster, and as well as hardware combinations and stuff. And so when you're setting the sail plan of your frigate or your sloop, you know, only experience for your particular use case will tell you. I look at load, but we also look at read latency. We look at pending tasks. And a lot of times, it may not necessarily be a matter of expanding your Cassandra cluster. It could very well be a matter of creating a new smaller cluster for a special use case. Our online cluster, they turned a new algorithm on it, and they were just hammering it, and it was causing latency issues in our front-end serving API machines. And it turned out that there was one algorithm from this personalization that was just causing spikes on usage like minute by minute. And it was doing batching, it was doing all this stuff. And it made more sense just to make a small cluster for it and isolate it. So that when those machines did a call, when those servers, those front-end servers did a call to those different Cassandra clusters, we could set timeouts and expectations to be differently. That's why I kind of like segmentation. And also different teams within my company have different levels of experience and different expectations from Cassandra. So isolation can be pretty good when you're a large distributed team. So I don't have a good answer for it other than, you know, look at it. Anyone else? Anyone else? No? Oh, what's up?
With those solve commands, how do you, is there a way to display them so they run, do they run end to end, do they run all at once, how does that work?
They run all at once unless you do batch, and then you can do batch with one, and you can do it serially, or you can do it 25%. It can do it, you know, there's a whole bunch of options I didn't show, and there's a whole bunch of modules for it too that are fantastic. There's MySQL modules, and ifconfig modules, and all sorts of stuff. So, you know, we actually use it as an underlying bus for one ring to get information from nodes and make decisions. So it's pretty handy.
Do you have any kind of like automation bar starters for someone setting something in the wrong place, or any sort of quick double checks that you put in your systems to
we haven't had anything so horrific. What does happen sometimes is we're doing an IP address migration, and we will change to a new IP address schema. That's one of the things that happens when you scale and you own your equipment and you're in charge of creating IP addresses and you don't know what you're doing. You've got to redo it all. And when we did that, we have Chef manage the host file or the resolve file. And it also manages LDAP. So when DNS breaks, LDAP breaks. And one of the problems in our infrastructure right now, at some point when we LDAP'd everything, service accounts like the Cassandra user and the MySQL user and the Tomcat user were LDAP'd. And it was a decision that you look on in his, in hindsight, and you're like, that's probably not a good idea. Because if you change IP addresses, then you can't connect to the LDAP server, and you can't look up the host name from the LDAP server, Cassandra, because you can't authenticate the user. So that has happened and caused big problems. But we actually have a very resilient, service-oriented infrastructure. We've got a lot of different big moving parts. When Sandy hit and we lost our master database, we actually, well, me, I was out of town and I was, and everyone else in New York couldn't get internet. But all the folks in our Israel office were working round the clock to finish up the DR tasks that weren't totally done. But at that time we only had the one Hadoop cluster in New York, and it was kind of core to what we do. Now we have several. We have 3 Hadoop clusters. But when that Hadoop cluster was down, we weren't generating fresh data. So for the course of a week, we were still serving. We only lost 5 minutes of traffic from the data center before we failed over. But we are resilient enough architecturally that we can lose huge swaths and get it back up online. That's why I use things like Cassandra without, user-facing issues. But nothing really truly horrid yet. I expect there will be now that salt is a thing. We do actually give a select group of developers in our environment root access everywhere. We have a lot of trust for a lot of people. So we keep things like that open, but we still want an audit log so that we can, reverse engineer if something does go wrong. In our Chef environment, I give everyone access to use Chef. Anyone can use Chef. I have guidelines, and I like to have a little bit of review on their cookbooks. But if they're dropping a new FS tab, trying to mount an NFS share, rather than using the mount resource in Chef to do it for them, that's a problem, and that's happening. But it hasn't killed anything yet. No one's died.
You mentioned putting in resolve.com the IPs. You put it in there in case you can't ask those now?
No, I mean oh, you mean manage a host file?
No.
There's a guy